Introduce at first a little bit background of myself. I'm from Bangladesh, and I'm currently enrolled in my master's program in civil engineering at University of Victoria. And my supervisor is Professor Kaitono Doria, and my research topic is on fecal sludge. And I completed my undergrad in civil engineering back in my home country. Then I started my career in construction for more than 3 years. And after that, actually moved to the humanitarian sector. Then my first job in the humanitarian sector was with Terrace Homes, which is a Swiss-based NGO. And I used to work there as a WASH infrastructure officer. Then I also worked with Solidarities International, Action Contre l'Afiam, and my last organization was the International Federation of Red Cross and Red Crescent Societies. So I used to look after the WASH projects in 7 different camps, as well as the adjacent local communities. And my WASH projects was include the water supply networks, installation of hand tube wells, and construction of latrines, bathings, institutional wash blocks, and also the construction of fecal sludge treatment plants, material recovery facilities, as well as hygiene promotion sessions and wash and non-food item distributions. So without delay further, let me go through my slides. Today, with a brief overview of the Rohingya response, I will try to take you through the entire sanitation chain for Rohingya camps to explain the changes, adaptations, developments, and few innovations related to fecal sludge management in Cox's Bazar. Cox's Bazar actually is a sub-district in Bangladesh, which is nearby the Myanmar border. So maybe most of you are well aware of the Rohingya crisis in Bangladesh. Let me explain a bit about this crisis who are not familiar with it. The Rohingya crisis actually started in Cox's Bazar in Bangladesh in 2017. More than 700,000 of Myanmar national fled from Myanmar to escape the massive violence like genocide. These mass migration actually resulted in one of the world's largest refugee settlement with a lot of pressure on basic services like shelter, food, health, education, and definitely the water and sanitations. So the current population growth rate in the camps is actually 30,000 per year, and currently around 1 million of Rohingya refugees are living in 33 makeshift camps. Currently, 3 UN agencies and more than 100 NGOs and INGOs are working over there to serve this vulnerable community. But still the challenge is there, and still they need support to continue to provide the basic services with minimum standards. And the shelter size for a family in the camps is actually 10 to 15 square meters, and often shared by 5 or more people. You can imagine how difficult it has been for them to live in such a cramped condition for more than 7 years. And still they don't have any clear idea when they will be able to go back to their homeland. The Rohingya camps is actually located in hilly terrain nearby the sea. The climate in this region is tropical, such as with hot and humid conditions for most of the year. And it experiences heavy rainfall during the monsoon season, basically from June to October, and which often leads to flash floods, landslides, and also other cyclones and damages to the wash and shelters and other infrastructures regularly. And in the dry season, the temperature rises to 35 degrees Celsius or sometimes even more. So it's really difficult for the refugees to live in such a congested area with these cruel weather conditions. Here you can see the bird's eye view of the Rohingya camps, the tiny shelters, the latrines, the small pathways. And on the right side, this is the map for the 33 makeshift camps. These camps are located in actually Ukia and Teknaf. Ukia and Teknaf are actually the sub-district of Cox's Bazar, which are nearby the Myanmar border. I believe most of you are familiar with the diagram, the sanitation chain. As you know that in the sanitation chain, the first two components are the capture and containment. So let me share what's happened during the emergency and after emergency. So during the emergency phase, many WASH actors actually focused on constructing emergency latrines with very minimal materials like just a tarpaulin and bamboo as a superstructure. And the containment type was a single direct pit. And the size of the diameter of the pit was around 0.75 to zero point 0.9 meters. And the depth was around 1 to 1.5 meters. That's it. Uh, and during the emergency, the coordination between the actors was very limited. So wherever they got free spaces, they built latrines and hand pumps to provide the water supply and give the access to the sanitation services. As you know that as per the SFAIR standard, there should be minimum 30 meters of distance between the latrines and water sources to uh, prevent the water source contaminations. But during the emergency phase, it was very difficult for them to maintain such kind of standards and also to provide the immediate support to the vulnerable communities within a very short time. But later on, over the time, more strategies and guidelines were adopted, and including some distance requirements for water sources from latrines, and also regulations on the types of the water sources. So if you see this is actually the emergency latrines made by tarpaulin and bamboo, and gradual upgradations was made by using only CGI sheets and bamboo. Here you can see the water sources. The shallow tubules actually was the most common water sources for drinking water at the time. You can see how close it is from the images from the latrines. So later on, based on the strategic guideline, WASH sectors actually started the construction of solar power water supply network systems and installation of deep tubules. So that currently the community is collecting their drinking water from the tap stands operated by the solar power water network supply systems, and they're also using the water from the deep tubewell for other purposes. So from 2018, a unified design was developed after the emergency. The unified design was developed to replace the temporary emergency latrines. The new design was incorporated with RCC pole, CGI sheets, and wooden frame. And also more sustainable containments was also considered at that time, such as single pit, twin pits, septic tank, and the diameter of the pit was increased to 1.2 meters and depth was increased to around 2.5 meters. And also, we also introduced biofuel and biogas systems over there, but this biogas and biofuel system was not accepted by the community due to the unpleasant odors. And also, this community tend to use huge amount of water for the cleaning and toilet flushing. So, biogas and biofuel system actually was not successful in this context. Over the time, some modified pilot latrine designs were also implemented by different actors to make the latrines more resilient to the disasters. And one of the successful pilot design was steel frame latrines. I will explain a bit later why the steel frame latrines are more resilient to the disaster. And at the same time, more inclusive latrines design were also introduced, especially for women and people with disabilities. Till 2024, actually, we faced several cyclones, floods, flash floods, landslide, and also massive fire. You can see this is the picture of a massive fire that we faced in the last year, 2023, in March. So after this fire incident, there was nothing actually, everything was turned out into the ashes. So from this experience, we understood that the latrines which was made by the wooden frame were completely destroyed, but there were some latrines which are made by steel frame were partially damaged. So from this experience, WASH sector actually recommended all the WASH actors to modify their latrines, to upgrade their latrines to the steel frame latrines so that it will be more resilient to the disaster, and also it is also another benefit that it require less operational and maintenance cost compared to the wooden frame latrines. Here are some examples of the inclusive latrines, which are basically for the women and disabled people with special abilities. And this is the steel frame latrines with hand washing device that I was talking about. And when it comes to emptying and transportation, practices in the camps are actually at the time of emergency. Most actors relied on the manual emptying methods using only buckets and manual diaphragm pumps. And later on, mechanical methods were introduced, such as robin pumps, drainage pumps, and vacuum ducts. So this is one of the example of manual dislodging or manual emptying of the pits. So basic tools such as bucket, bamboo, shovel, rope are typically used for manual emptying. The sludge is actually collected into 50 to 60 liters of drums when it's fill up with 80% of its capacity. The volunteers actually transport it to the burial site or either to the treatment site. Here you can see the bamboo stick at the hoy and there is also another hoy at its end, so which is used to stir the thick scum layer into the pit. Once the liquid part is collected, then some portion of the settled solids in the pit are collected by using that hoy from the bamboo stick. While collecting the sludge from the latrine pits, it was not only the sludge. There was also solid waste. Volunteers have to collect it. It was kind of a hidden treasure at that time. During the time of emergency, we used to get a lot of unwanted solid wastes like plastic bottles, sandals, menstrual wastes, and so on. A lot of things we used to get. But nowadays, it's the amount of solid waste are very minimal. This improvement is made due to the behavioral change and awareness sessions to the community based such as the topics that we used to cover in the camps, so how to use the toilet properly, the environmental hygiene and waste disposal processes. Another tool used to collect the sludge from the latrine pit was a manually operated diaphragm pump. This pump is actually capable of extracting low viscosity fecal sludge. I will not explain how it works. If you Google it, you will find it. So these two methods are actually very time consuming, especially when you are serving a large community within a short time. Later on, agencies started using drainage pump and robin pumps, though the drainage pump are not used that much. From 2018, we are actually using the robin pumps mostly. The robin pumps actually equipped with two types of, one is inlet. There is one inlet and outlet in the robin pump. A flexible hose pipe connects from the inlet to the latrine pit to extract the sludge. And while another hose pipe is attached from the pump's outlet to discharge the sludge to the collection tanks, or directly to the nearby FSTPs. And another mode of mechanical collection is vacuum duct or vacuum duct, but the large vehicles are often unable to access to the narrow streets during the time of emergencies. But nowadays, the roads are more accessible. The conditions are very good, and agencies are using the vacuum duct very efficient way. When it comes to the transportation, there are also two methods, manual and mechanical. The manual transfer involves human labor with drums and push-pull carts. Although these manual methods are not advisable, but during the first phase, I mean the emergency, these are the methods that used mostly. The practice is still available in some camp areas, but not that much. Where there is access issue, we have to use this manual method still. So on the other hand, the sludge can be collected efficiently and transported through the different kind of mechanical means, such as small pickups, vacuum trucks, trucks with large tanks, and the last one is the intermediate fecal sludge transport network. And these methods that I highlighted in the red are no longer recommended by the wash sector in the camps, as there is a chance to spill out of the sludge from the drum, so that it is a potential risk to the public health and environment. So these are actually not recommended anymore in the camps. Here you can see some examples of the transportation. If you see from the left, you can see two volunteers are carrying a 50 to 60 liters of drum from a bamboo pole. Below the drum, there is the blue drum actually with this is actually a cart and with the blue drums. This is actually push-pull cart, which are operated by the volunteers to carry the sludge from the latrines to the FSTPs. Later on, when the roads became more accessible, agencies started vehicle and trucks with large tanks to transport the sludge to the treatment site. However, there is a limitation to use the vehicle. The vehicle actually can extract the sludge from the latrine pits, which are very close to the streets. So to overcome these challenges, agencies started installing the holding tanks or collection tanks nearby the roads so that they don't need to wait anymore for the vehicle trucks. They can collect and they can extract the sludge from the latrines by using the robin pumps that I mentioned before. They can store this sludge into the holding tanks so that the vehicle trucks just simply come and they can this can simply collect the sludge from those holding tanks and transport it to the nearby FSTPs. The last one is the intermediate fecal sludge transfer network, the figure which is we call as a IFSTN. So to overcome the challenges of manual dislodging process and transportation of the sludge, the IFSTN was introduced. With this network, the sludge can be pumped directly from the latrines to the FSTP by minimizing direct physical labor as well as minimizing direct contact with the fecal sludge. Also, it can maximize the dislodging or collection rate from the latrine. As the fecal sludge in the camps are mostly liquid, so it can be easily pumped in medium and long distance routes with dislodging pump and portable pipes and number of series of the tanks. I will explain a bit how this how this intermediate fecal sludge transfer network works. So this is actually the process diagram of the intermediate fecal sludge transfer network. If you see the picture on the right side, you can see the volunteers are actually collecting the sludge from the septic tanks from a latrine, and this sludge can be transferred to the transfer station either directly or through the transfer pit or box. And from this transfer station, the sludge can be transferred to the FSTP's collection chamber through a series of tanks. These tanks actually are connected with each other by flexible pipes. And the number of the tanks depends on the distance and location of the FSTPs. So this is very efficient way to collect and transport the sludge from the latrines to the FSTP. So every month, we have to collect around 29 cubic meter of sludge from the latrines, and we have to treat it in the designated FSTPs. So through the analysis, it was identified that the intermediate fecal sludge transfer network is the least costly method to collect and transport, whereas the manual and vehicle was the most costly method in terms of collection and transportation. So as per the cost measure was sector FSM strategy, the manual methods are not advisable anymore. There are some recommendations and challenges regarding collection and transportations. And the volunteers and operators who are actually engaged directly with the collection and transportation process, they must use proper PPE, I mean the personal protective equipment. And there are also some challenges in terms of collection, such as accumulation solid sludge at the pit, and the unwanted solid waste can create the blockage in the pipes. And sometimes the dislodging rates becomes higher during the rainy season, and also sometimes it happens due to the maximum number of toilet users, and also sometimes it depends on the low capacity of the containment. When it comes, let's talk about some treatment and safe disposal. So at the treatment stage during the emergency phase, basic methods were commonly used, such as open dislodging pond, geotube, and mobile lime stabilizations. So sludge was actually at the emergency phase, sludge was typically managed by only pouring it in the excavated pits nearby the latrines. And sometimes we used to bury the sludge into the ground. We sometimes with lime treatment and sometimes without lime treatment, but we have to manage it within a very short time. And in some cases, the sludge was stored in the open desludging pond. This is the pond where we used to store the sludge. And this is kind of a modified geotextile tube, where also we used to collect the sludge from the latrines. We stored it inside the geotextile tube. And after a certain period, we have to also again collect the settled solid portion from this ODP and geotube, and we have to bury it into the ground. And later on, various treatment technologies were introduced with two different approaches, such as centralized and decentralized FSM. The centralized FSTPs are those which have the capacity to cover more than 2 or 3 camps, and the decentralized FSTPs are those which has less capacity. And in one camps, there could be around 8 to 12 decentralized FSTPs unit. And currently, 70% of the camps are covered by the decentralized FSTPs, whereas the remaining are covered by the centralized FSTPs. And the capacity of the decentralized treatment plants are around 5 to 20 cubic meter per day, whereas the capacity of the centralized FSTPs are more than 100 cubic meter, or sometimes it is 150 cubic meter per day. So currently, around 165 or even more than that treatment plants are operational in the camps with various technologies. Most of the technologies are biological treatment, such as anaerobic bioreactor, planted drying bed, upflow filtration systems, waste stabilization pond, aeration systems, anaerobic lagoon, and there are also some other treatment technologies in some camps, but these are the most common technologies that are available in the camps. There are few plants which follow the chemical treatment, which is the lime stabilizations. And there is also another high-tech technology, which is high-tech FSM, which is omniprocessor, and this is very expensive. And all of these fecal sludge treatment plants are constructed and operated by different NGOs and INGOs. When it comes to the reuse and disposal, still it's challenging in the camps. Most of the FSTPs still bury the residue from the treatment plants into the excavated pits, and only few facilities have the incineration like this, and to burn the solid portion. And some agencies currently started the co-composting project by using the solid portion, but still it needs some time to understand the market, and also to get the understanding of acceptance rate by the community. And for the liquid effluent, some plants discharge it into the nearby water bodies, and whereas some plants also have some wetlands and polishing pond to manage the liquid portion by infiltration and evaporation process. As I mentioned, that there are around 165 FSTPs are operational in the camps, and more than 1 million Rohingya peoples are living over there. So it's very crucial to maintain the quality of treatment and also to monitor the effluent quality. So in 2019, a monitoring framework was developed to monitor the effluent quality, and there are actually 3 to 4 fecal sludge management lab in Cox's Bazar, which are operated by different NGOs and INGOs. But in those labs, they actually test the quality of the effluent of their which are solely operated by them. But what will happen to the rest of FSTPs which are operated by other entities and who don't have any FSM labs? So to minimize this gap, Department of Public Health Engineering Department, DPHE, has established a fecal sludge management lab in Cox's Bazar, which is a central lab for the Rohingya camps. They usually test these parameters in the central lab, which is pH, biological oxygen demand, chemical oxygen demand, some nutrients, total solids, and also total chloriform. So In this lab, they collect the samples from all the FSTPs 3 times in a year. That means 3 rounds in a year. They collect all the samples from the effluent from all the FSTPs and they upload it in the website. Let me show you how the website works. So on the left, this is the effluent quality monitoring dashboard, which was developed by DPHE and also Cox's Bazar Wash Sector, so that all the agencies can access to the dashboard and they can check the quality of their the quality of the effluents of their FSTPs. So this is the some pictures where the DPHE laboratory technicians are collecting the samples from the FSTPs. And also, and this is the central FSM lab for Cox's Bazar. Some innovations and learning. Through facing many challenges and gaining experiences, agencies trying to introduce innovative solutions to increase the efficiency of wash services with minimum cost. So one of the innovation was pit intelligence tracker app. This tracker mobile application is actually used by the operators so that they can check uh, they can monitor the pit on in real time. They can check the when the pit. They can understand through this app. They can understand when the pit will be filled up and when the pits need to be emptied. And another, as I mentioned before, the biogas system was not accepted by the community due to the bad odor. So there is other way to utilize this resource. Therefore, UNHCR and Oxfam has started a pilot project to produce the electricity from biogas so that this electricity can be used in the fecal sludge treatment plant itself, such as this electricity can be used to run the generators, pumping out the water, and to run some of the utilities like lights, fans. Still many of organizations are working on some few innovations. They're still on trial of they're trying to innovate something new for more sustainable sanitation solutions in terms of fecal sludge treatment. So what we have learned over this last 6 and 7 years. One thing is that we should not just copy paste the design and BOQ of any successful FSTPs from other contexts. And also we should remember that the fecal sludge, the characteristics of fecal sludge and the wastewater are not similar. And the wastewater treatment plant maybe works in other contexts, which will not work in other contexts if we just copy paste it, and which works well in the urban context may not work in the emergency. And by considering the factors such as future demand, containment type, soil characteristics, user behavior, and also the water uses, stakeholders can design the fecal sludge treatment plants that can be adequately sized, which will for more effective and sustainable sanitation solutions. And a comprehensive plan is still needed for solid storage, for further treatment and proper final disposal and utilization of the byproducts. It is also critical for ensuring public health and to protect the environment. And if it is any refugee or informal settlements, then and also for the regular context, the regular capacity building for the FSTP's operator are very important to improve the operational efficiency and to train also to maintain the quality standards. And when if we say about the emergency or informal settlement for the refugee context, when the volunteers, the trained volunteers will go back to their homeland, they will be able to manage the fecal sludge management by themselves, and they can ensure they can contribute to the health and well-being of their own community. So these are some learnings from our experiences in Rohingya camps in terms of fecal sludge management. I think I'm on the last slide. If you would like to know more about the fecal sludge management systems and some other resources related to it, you can explore to the Cox's Bazar website, Cox's Bazar Rohingya Response website. You will get a lot of resources related to fecal sludge management as well as some other wash components. You are welcome to explore the website of Rohingya Response in Cox's Bazar. So I think that's all from my side. Thank you for listening to me and thank you for your patience.